Right. Thanks everyone for coming, and welcome to this session on mobility and distance. I'm going to jump right into it, but before I do, a quick reminder, please, when you're presenting and sharing screen, have the chat window open on your screen so that you can see when I message you for time purposes. Let's jump right into it. Our first presentation is from Golan Ben-Dor, Ido Klein, Alexei Ogolenko, Ellen Benelia, and Itzhak Benson. Do you guys know who wants to present?
And I am presenting.
Fantastic. Right, take it away. Best of luck.
Okay, thanks. So my name is Golan, and I'm going to be talking to you about congestion and parking prices in a shared automated vehicle future. A case study of Jerusalem. This study is with Ido Klein, Alexei Ogolenko, Alain Benelia, and Itzhak Benson. So we're using MATSIM. MATSIM is a multi-agent transport simulation. It's Java-based, it's open source. It's used around 30 research groups around the world, and it has 4 big benefits. You can do large-scale simulations of a city or even a country. You have microscopic traffic modeling. You can have a vehicle and see where it is on the link, buses, passenger, and so on. You have microscopic behavioral, meaning that you have activities of millions of agents. So this agent has a home activity and work and lunch, and he has different desires, and he uses different modes to get to his activities. But MATSIM also have complex adaptive systems, meaning an agent can change his departure time, he can change his route, he can change the transport mode. So in a given day, an agent try a bus to get to work, and if it's beneficial for his daily utilities, he will use it the day afterwards. So how does MATSIM work in the scoring and adaptation? I will go with you fast on this kind of scheme. So you have in the x-axis the time and the score. This is of a one agent, and MATSIM works on a single day. So you get a user equilibrium of the end of an average single day wherever you're simulating. So you can see when agent is at an activity, he gains positive score. When he is at home, workplace, at lunch, and he cannot gain, he cannot stay at that activity forever. This is the marginal utility. And on the other hand, when you're using a mode, car, bus, or whatever, you get a disutility, you get a negative score. So car, you have a bigger penalty than bus because you have insurance, you have fuels, and so on. And then you get a daily scores. A million of agents get this kind of scores, and they try different modes. And in the end, you have user equilibrium when an agent cannot improve his score during each iteration, and iteration is a day. So this is our model for JMA. JMA is Jerusalem Metropolitan Area. This is Israel, if you're not familiar. This is the north. This is here is Tel Aviv. And this is Jerusalem. And you will see now the triangles, which represents private vehicles, and the color schemes from green to red is traffic. And it's now early in the morning, so there's no traffic. And right about now, we're going to see public transport. And what we see in this blue hexagons is the capacity of passengers inside public transport. And this is the real strength of agent-based simulation. You can see particular effects that you cannot see in aggregate models. So this simulation is with 500 more or less agents. It's 30% of the population. We're using a method that is called downscaling. We published a paper. We're not going to get into it. We have 3 types of agent with different behaviors. We have secular Jews, Arabs, ultra-Orthodox. In real life, they don't get along, but they know which the shortest path to go through. So that's important. We have GTFS, which is General Transit Feed Schedule from Google for the public transport. We have traffic counts for validation, and the network is an MEM network for traffic engineering. So here you will see now schematics and dynamics of the agents. You can see when I will start the video, you will see each dot will click when the time passes by. Now it's in the night, everybody is at home. And I'm going to click it, and you can see everybody is still at home. Some are going to work early in the morning, and they're going to school. So you can see also the agent activities, and you can see behavioral that are not related only to traffic. So I'm moving forward. We calibrated the model against traffic counts. So here in the x-axis, you have counts on links, and in the y-axis, you have simulation volumes from the simulation. And this is aggregated for the whole day. The correlation is also right if we look at different time steps. So if we just put everything inside, run MatSim, put the right parameters and everything, we see a high fit of 0.65 R² between traffic counts and simulation volumes. When we calibrate it, I'm not going to tell you how and why. If somebody wants to ask, he can. We get a higher fit. And if we remove the dongles from the exit links from the Jerusalem area, we get a higher fit. We also calibrated the model split against the travel survey. We used utilities from the simulation from the open Berlin scenario, and we just play with the constants until we got a good match to our mode choice split. So now I'll be talking to you about the effect of congestions and parking prices in Jerusalem center. So here you see in the purple is the Jerusalem metropolitan area. Here in the green on the right, you can see the Jerusalem city. And in the reds, you can see the city center and a wide attraction areas, hospital, working zones, and so on. So we wanted to simulate what will happen with congestion pricing only for car users, which are arriving to the red areas, the city center. So we tried €5 until €20 of congestion fee of once entering the area. We tried parking prices. We also tried a mixed scenario with congestion pricing and parking prices. And we're now writing a paper. We have more scenarios for that. So here you can see the results of the dwell time of different scenarios. So with €0, you can see the dwell time of each area. And if we use the 5-hour parking prices, you can see that it tracks shorter period time agents. And if we do the scenario with the 10 congestion prices, it tracks long activities, and the 10 congestion and 5-hourly is quite similar to the parking prices. And here we can see the daily tax collection of each area and the total 24-hour revenue. And this could be also beneficial for the policymakers. They can take the money, put it back into public transport, maybe in a shared service like we'll show you in a minute. Here we can see on the left the number of car trips who are entering all those areas with different pricing, right? We have parking prices and congestion pricing. So we can see that around €10, we can reduce congestion about 15% more so. And this €10 parking price, congestion price is the sweet spot that the effects of congestion pricing is beneficial. So here we can see the map of the city center, and we can see the volume to capacity ratio, it's V/C. So meaning that clogged links are more into a value of 1. So here we have 0 price, €5, €20, €10, and this is congestion pricing only. So we can see with €20, we eliminate all the red links, right? All the clogged ones, and no congestion anymore. And if we look on the left, if we check the vehicle to capacity ratios of links that are higher than 0.25, which are highly congested links, above 10%, about 10 congestion price, you have very, very low links. And even if the numbers here are small, by the way, of the share of links, you need to remember that one link in the city center can make traffic jams everywhere. We also checked what happens to the people who are driving to the congestion price area. So we did simulations of free speed and compared them to the simulated one. And what we actually found that congestion pricing, when it's higher, we have agents who are traveling from farther away coming because their utilities of the traveling and paying is kind of mixed up. And now I'm going to talk to you about the shared automated vehicle simulation, which we will concatenate with the parking and congestion pricing. So how does the algorithm of SAV shared automated vehicle works? So in response to an agent request, agents departed their home, take the phone, they order a ride-sharing vehicle, and the algorithm checks that it can arrive to him before the maximal waiting time. It's about 10 minutes. It has a vacant seats across the whole route. And this is the important part. It checks that the new agent ride will not be less than this formula. What's this formula says that it checks the direct time. So if we have a direct time of 10 minutes without ride sharing, and we have the alpha of 1.5, meaning that the trip will not exceed 15 minutes with a ride share. And also another condition, if you're already inside and your trip could not be 5 minutes more than your direct trip, it checks that it not violates for other people, this kind of behavioral. And then it checks the vehicle with minimal average time for all passengers, and it given the user that vehicles. And you have cases where you have rejections because there's no vehicle to satisfy all those conditions. So the study of the SAV effects. So the SAV service are pick up passengers at public transport stops. We had a research where we checked door to door. Public transport is more beneficial, and inside the service area, right? And also in a case of rejection, and agents just continue. We made them smarter. If the agent got rejected, he chose the previous plan that he had, PT or car. This wasn't inside the algorithm. The SAV price is the same as PT, very cheap, and empty SAV parks at the end. So the scenario we have are with vehicle capacity of 10 seats, a fleet of 250 vehicles and 1,000 vehicles. And we check two kind of SAV services or algorithm. One algorithm is full, meaning that the SAV serves everybody inside the whole Jerusalem metropolitan area. And the other one is core periphery, meaning that it will only serve agents who want to go to the city center areas. Those same areas where we gave them parking and congestion price. We're now trying to see if we give them a different alternative, will they choose SAV there? So here are the results for SAV. So we can see 3 Sankey diagrams. And this is a core periphery service, not the full service, with 250 SAVs. So with €0, you can see that with 250 SAVs, we have 2% of DRT. DRT is SAV, dynamic ride transit, it's the same. And most of them, you can see down below, come from PT users and walk, not from car. So when we put parking prices, 5 hours per hour or 10 euro congestion pricing, you can see that it doubles the number of car users using now SAVs. And there's no marginal after 10 congestion to raise the money more. So you wouldn't put 20 euros and everybody's going to be very mad. Why do you put that kind of price? So this is the real beneficial of agent-based simulation. You can check this kind of stuff, which you can't do with aggregated model. And we think that the future of the Jerusalem transport policy should have a carrot and stick, because a charge of 20 or 30 shekels, which is 10 euros, it will reduce congestion. And also parking prices, we saw that deters drives that arrive for a long time, while the congestion prices deter drivers that arrive for a short period of time. And also for the condition of 2020, SAV or other services of ride sharing mostly track PT users and just add to congestion. So this is kind of not contradictory to empirical observation that DRT will not be the ultimate mode as everybody thought in the start. So in case of charge interest to the city centers, SAV service becomes an attractive alternative for the users of private cars and reduces congestion. You know, I have 1.5 minutes. I just want to say what we're doing next. We're now testing this kind of same scenarios for a scenario of 2040, where the traffic will be clogged with new public transport lines, with a metro, with everything. And we're also trying to modify the algorithm of the SAV to be smarter, to check if people have similar trips starting in certain times, kind of pre-booking instead of just going out and ordering a shared automated taxi. So thank you. And if you have questions, I'm here to answer.
Thank you very much, Golan. I think we're going to save discussion and questions for our discussion session at 1 o'clock. If you have anything else to add, you still have time before we move on?
No.
No, fantastic. Thank you very much for that. Our next presentation is asked that the recording be paused. So let me do that now. I'm not sure how Zoom works in terms of messages and recording. I think once we've started recording, all messages are saved. So even if you sent them while we pause the recording, it should still be available for all the questions you asked. Anyone who missed it, Golan Ben-Dor will not be able to join us for the discussion. He's left his contact details. If you have anything to ask him, please reach out. Our next presentation has a lot of names to it. Satoru Kumagai, Kenmei Tsubota, Toshitaki Gokan, Kazunobu Hayakawa, Ikumo Isono, and Saukmilan Gola. I'm so sorry to all of you. I apologize so sincerely. Please take it away.
Thank you very much for giving me this opportunity to talk and also calling our names. Probably it is a bit strange to you, but all the mostly coming from Japan. And today we are going to talk about Indian case. What we do is that the introduction of the freight railways, how it will change the economic situation and also environmental impacts. So usually that in our conference, I would say that please come to Japan and contact me if you have such an occasion. But then this time I don't have such an occasion to talk to you. So directly, please send me an email if you come to Japan after the COVID. So let me start. Results in brief. So this time we use the economic model which incorporated the spatial dimension in detail, and we have the agglomeration economies in one point as a model, and also modal choice and detailed geospatial data. These are the features of this model, and what we do is we show the synergy effect and the economic impacts and the environmental impacts. I will talk later in detail, but basically we analyze the benchmark case and the Eastern DFC, dedicated freight corridor, Western DFC, and both. So yeah, so there are two corridors, Eastern one and the Western one. Delhi is here, Kolkata is here, and Mumbai is here. So basically, the main cities are connected with these two giant lines. But as you see that the Delhi is the inland. So how to open up Delhi is a big challenge. And this railway will open it up and also they connect to the foreign market. So this is vitally important. This side is supported by the World Bank, and this the other one is supported by Japanese JICA, the ODA agency. And so, yeah, I will talk that how we can see the economic impacts and also how we see the environmental impacts. So, in short, since the railways have the less impact or mainly the currently most of the freights are transported by trucks and will be diverted into the railways. So the CO2 reduction will happen. And then economic impact will be increased, but the environmental impacts can be reduced. So it's a very good news, is our result. So today's talk is about why India needs the corridor and what we do with our model. And probably we skip the model in detail and we will go into the results and conclusions. Okay. So I talked about it already. So probably I would, firstly, why India needs it. Yeah, because India equipped the railways in the 19th century with the latest one, but they are still using the latest one at the time. So it's a very big difficulties. So they have the very expensive fare, about nearly double of USA and China. And it is very slow. It's not like the one like in Germany or some other countries. So it's very slow and uncertain in terms of the arrival time. So the manufacturers try to avoid using the trains. And yeah, if you want to take a train in order to go attend the conference, then probably you will miss your presentation. So don't take trains, take bus or your car. So then delays are frequent, and the trains. Why delays are frequent? Because there are passenger trains and freights. So and passengers have some priority. So freights transportation have to wait a little bit. Then delay will be doubled or tripled. No assurance of arrival time. We never know when it will arrive or when we can arrive. So DFC has a double purpose, reducing the transport costs and reducing the increasing the reliability, not reducing. And there is an economic impact, enhancing the trade with cheaper freight rates. And what is the spatial economic impacts will be analyzed. And how large are they? And how about environmental impacts? So it will promote the modal shift from to railways, from trucks. How large are the environmental impacts? We will see. And how can I say? These analyses are in line with wider economic benefits, which comes up in recent literature that the cost benefit analysis may be too narrow in the sense of the analysis. So probably we can incorporate the spatial economic impacts or the indirect economic impacts. It was proposed by OECD and UK Department of Transport. So then now come back to what we use as a model. So this is IDE. This is the same with this one. Most of us comes from. And our institute, Institute of Developing Economies, made one simulation model called GSM, Geographical Simulation Model. It has a spatial economics feature, which has a different name as a new economic geography. With the core is agglomeration economies in the population and manufacturers or services clustering. So the both factors are in it. So this is very good in a sense that Asian cities are mostly urbanized and highly populated. So these are very important. And since we use the regional data, it's not national level. The railways within the country cannot be analyzed with the country level data. So we have to have the detailed district data or at least the provinces or states. But now we have the second or lower or smaller ones, so we can analyze a bit better in the sense. And also at such a level, we constructed the data by sector. We put lots of efforts. And we have air, railway, road, and ships. So we can examine the modal choice among these transportation modes. Yeah. So let me show you the coverage of the data. So mostly regional level. So only some regions are at the country level, but our focus is mostly the developing countries. So except some of the European countries. So here are our targets, and we have detailed data of the truck, railway, and sea and air. We differentiate the quality of the infrastructure. So the average speed are different, and also waiting time are different at each, let's say, port or stations for changing the transport mode. Then what we do is beyond cost benefit analysis. Usually cost benefit analysis would calculate the cost and compare with the benefit, how much they can save the travel time and vehicle operation costs, and how some of the direct impacts. These are the main factors. But actually, with reduction of the transport prices, it can invite more investment, or it can increase the volume of trade. So there are some economic impacts, and also probably if there are inverse direction of the modal shift, then probably environmental impacts are positive or negative. We don't know actually. So we calculated it. I think I can talk 10 more minutes or. Okay, then yeah, we have 8 sectors: agriculture, mining, automotive, E&E, textile garment, food processing, other manufacturing, and the services. And we have 3 types in terms of the specification of the functions. Agriculture is a constant return to scale, and the manufacturing are a kind of competition style called the monopolistic competition, but it requires some input from other industries. So it is called the input-output structure included. And the service sector has also similar structure, but it doesn't have the input-output structure. The service provider doesn't need to have automobile or yeah, something like that. And yeah. Probably I would skip here, but if you have any question, I can explain more in detail, but we have lots of transport costs specific to crossing the border, or going far, and also in the monetary cost and time cost, and all included. And we see difference in shipping apples and potatoes and shipping iPhones. They should be different. So we see these as different goods. Yeah, some things let me skip about the assumptions. Then what we can say this is the benchmark in the 2010, and to 2030, this is the benchmark growth. What I can say is that, please look at around here, how they can make some growth. So basically, China and India will grow, of course, but there are still some African countries cannot get out from these status, is one point. But then how these new corridors can boost it up is our question. And what we will do is taking the difference from the benchmark with a benchmark case and the result with corridors. Eastern one only, Western one only, and both at the same time. So the upgrade from 25 to 85, not 130 or 200. So this is the graphical result, Eastern one, Western one, and both. Please look at this table. So Eastern one will increase 0.57% of GDP per capita. Is very not negligible. And also 32 is the Western one. So only making one will bring about 0.57 or 0.32. Then if we make both, actually East plus West is smaller than both. So making both is better. can be found from here. So if this is less than 100, both is smaller, but this has the magnifying effect. So we would say there is a synergy effect of making 2 corridors, not 1. 2 is better. Then in terms of the environmental impacts, what will happen? So in the baseline, there is no difference because it's baseline. Then in the eastern one, there is a negative impact for the CO2 emissions. Western one has also CO2 reduction, and both has more impact. But let me say, this is the only modal shift in transportation. But we have to care the wider economic impact in terms of the relocation of the factories, or boosting up of manufacturing, or the increasing demand for tradable goods. Then possibly that if we have too big impact in the economy, if we have too much encouragement of economic activities, we can offset the negative reduction, so the reduction of the CO2. So we will calculate, this is the increase and the reduction. So minus, plus, minus, plus, plus, and then this is the result. We convert using some of the numbers and making the adjustment. Then the results show that Eastern one has a 0.75% reduction. Western one has a 1.4% reduction. Both will decrease 2.19. Which also show the East, West is smaller than the both. So not only environmental impacts, not only economic impact, but environmental impact has this synergy effect. So it seems that making both corridors would be better to make economy grow and environmental pressure lowered. So it is a result. There are spatially extended economic impacts found from the DFCs, and then both DFCs shall increase 0.96% of GDP per capita growth, and making both will bring synergy effect, 0.07. So it's like the extra of making both at the same time. So in order to get it, let's make both. And actually it is already in action. So we don't have to care, or we don't have to worry that we will lose these ones. And then, the net reduction of CO2 emissions. Modal shift will reduce the CO2, but the increase of the economic activities will literally increase the CO2 emission, but the net will bring the reduction of the CO2 from our model. So, from these results, what we found is that India is actually a very rare case. It is very inland. The highly populated regions are inland, and the demand for traffic, freight demand is very high and dominated by truck transportation. Where can we see the next potential regions? We don't know yet, but there would be somewhere which are waiting for the next dedicated corridor. Any ideas are very welcomed, or suggestions for another study. And we found that there are a double purpose, that DFC contribute to economic activities and also environmental pressure reduction. Yeah, so that's all. Thank you very much.
Thank you very much. That was a fantastic presentation. And we have just enough time, so we're all good. Let's continue. Our next speaker, returning champion, Alain L'Hostis. Do you feel ready? Alain, can you hear us?
Yes, I'm sharing my screen.
There we go.
I hope you can get it.
I can see it now. Yeah.
Okay, thank you. So hello again, everyone. So I'm Alain L'Hostis from Université Gustave Eiffel from France, and I will make a presentation out of a paper that we published this year with two colleagues. So I'm a geographer, and I worked with two colleagues from Department of Mathematics at the University of Paris-Est Créteil, Benoît Kleckner and Thomas Richard, and we have been working on this proposal of contextual metrics, contextual distance, as a mathematical definition for a comprehensive approach of geographical distance. So I will start my presentation with mathematical and geographical distance. So what are we talking about when we talk about these objects? In mathematics, a distance is a function, and from two locations in space, the function provides a figure, and this figure needs to be positive. There is also the distinguishability separation, which means that if the distance is 0, it means the distance is taken from the same place, same location. It's symmetric. And there's also this fourth property, the triangle inequality, and I will concentrate on this property. So it states that the distance from A to C is necessarily less than or equal to the sum of distance from A to B plus distance from B to C. And the meaning of triangle inequality, and I will now move to geographical distances. The meaning of triangle inequality is because distance is a minimum measurement. It's always a minimum measurement. So we minimize cost, we minimize time, we minimize maybe security. It can be a complex type of minimization, but it's always a minimum distance is always a minimum measurement. And we know by especially Uriotis Smith in a very important article in 1989 about geographical distance, we know that if we have violation of the triangle inequality, we lose the possibility to do spatial analysis. Stated simply, we lose the geography, the geometry of the space, because we lose this very important minimizing aspect of distances. And if we look into the literature, and especially in geography and to a lesser extent, economists, we have observed a big amount of claims of violation of triangle inequality, and I've demonstrated that most of them are wrong. In fact, all of them but one. I will explain that in the next slide. If the slide comes, sorry. Yeah. Oh, too fast. Sorry, 2 errors. Yeah. In the literature, there's most of the errors are about straight line versus path. As an example, Ahmed and Miller 2007, they say that triangle inequality violation are observed when, I quote, indirect routes are shorter than direct routes. There's also another example which is maybe more easy to grasp. If there is congestion somewhere, a driver will avoid congestion and take a longer route to get to his destination. And this is a violation of triangle inequality. And this is wrong. This is a wrong statement because distance is always minimum. Distance refers to a movement in space, a movement that occurs or that is potential, but a movement is in space, and the movement described by distance is minimum. So distances in geographical space very often have detours and sometimes have very long detours. And the way you define distance is at play here. And this confusion comes from the fact that we confound the straight line between two locations and the path between two locations. And the distance is a property, emanates, the measurement of distance is a measurement of a property of the path between two locations. So this is very commonplace, this error in the geographical literature especially. And the other error, which is less common, but nevertheless, it's in a very important document by Peter Haggett, in the Encyclopedia of Quantitative Geography, 2001. And it's an error related to optimality. I take this diagram and I've highlighted the diagram by Haggett. And Haggett says this diagram is about cities. And he says distance between cities. But these are not distances. These are measurements of length in time of path, but a measurement of the length of a path in time is not necessarily a distance. To make the example that I have highlighted is if I want to go from R to, from city Q to city S, the diagram tells me that there is a route, there is a path that takes 6 hours, but the distance from Q to S will take a path through R in 5 hours. So the distance between Q and S is not 6 hours, it's 5 hours. Haggett says that this is a case of violation of triangle inequality. I say it's not a case of violation of triangle inequality, it's a bad definition, I would say, of distance. And here, we have to distinguish the length of a path with the measurement of distance. And the measurement of distance should be based on the minimum. If it's a time distance, as it is the case here, it's time distances between cities, the time distance between Q and S and between any pair of cities should be the minimum path and not a random path or the path, the most direct route. Okay, so this is another error that we find in Haggett. If we look at all the literature on the issue of triangular inequality, there's only one situation, and it's again in this very important paper by Uriel Smith-Tiss of 1989, the issue of break. And I will explain in the next slide what is with some very pedagogical illustration. So what is the problem? The problem we have two cities, very distant cities, city A and city B, and it's a very, very long trip. So you have to drive 8 hours to go to a hotel situated in between, midway. So you drive 8 hours to the motel, and then you drive from the motel M to city B, and it takes 8 hours. the distance between city B and city A and city B is not 8 hours plus 8 hours. It includes a night sleep at the motel. You can't drive all the way through with a single driver in a car, as in my example. And if I do the easy summing of this example, so we have distance from A to M, which is 8 hours, M to B 8 hours. Distance A to B is 24 hours, so you have to spend the night. You need to spend the night to do this trip. So the distance is not 16 hours, it's 24. And this is where we have a problem, because distance from A to B is 24, and it's bigger than the sum of the two parts, AM plus MB. And it shouldn't be. It shouldn't be so, because this distance from A to B and the pass from A to B is a minimum pass. There's no quicker pass. There's no faster pass. There's no way to go faster and to take less time. So there shouldn't be a violation of triangle inequality. So with the mathematicians, we had this discussion, and there were two possibilities. One possibility is we introduce a new metric, a new distance that would lose the triangle inequality because we have this problem. The alternative would be to imagine a different distance that would respect triangle inequality, and this is the option we took because of the benefits it provides. So what is a contextual distance? The classical metric, the classical distance, is a measurement between two locations in geographical space. The geographical space is designated by a big X. So from x square to R plus 0 plus infinity. So this is a classical metric. We will introduce a context, enrich this definition with a context. So we not only have a measurement between two places in geographical space, we also have something happening between context C in C. So I provide this. I will illustrate on the next slide, so you will get the point. So we do not only measure what happens between places, we also measure what happens in a space of context. Okay, let's make it more clear. Let's go to the contextual motel case. So still we have on top of the diagram, we have city A, city M, city B, and we have enriched our space with a context. The context is really simple here. There's two states in the context. You are rested or you are tired. And if you want to go from city A to motel, you can't go there if you're tired. You have to be rested before you go to the motel. So the arrows have a meaning in this diagram. So every movement in space or in context is very simple. It's always 8 hours. And there, if you are in city A but you are tired, you have to sleep, basically. You get rested, and when you're rested, you can drive to motel. And when you arrive to the motel, you have to rest again before you go. Before you travel again from motel to city B. So in this diagram, you can compute, and there is a respect of triangle inequality, because from A to M, the minimum, there are several there are several possibilities to go from A to B, which depends on which state you start your journey, which context you start your journey. But if you, the shortest path is you start from rested in A, you go to the motel, you spend the night, and you drive again to B, and it's 24 hours. But there's no violation of triangle inequality, because if you want to go from A to M, you have to consider context. And in the addition that we have, sorry, I go back to the definition of the triangle inequality. In the context distance, you have to consider the context where you are when you do the addition of the AB to the BC in the motel. You have to consider the context. So you have in the contextual motel, you have a definition of distance that contains breaks in movement, so your recharge movement, and there is a respect of the triangle inequality. And this is a demonstration that this violation of the triangle inequality was an artifact of a model that was lacking crucial information. And this violation was an artifact, and we have a proposal that reconciles geographical distances and geometry, which is something we could wish for. So as a conclusion, what can we take away from this proposal of the contextual distance? What we call context is a resource that is not spatial. It's not related to space. It's related to movement. And when you move, this resource is altered in a way or another. So this framework of the contextual distance can cover resources like budget. And by budget, I mean money, monetary budget, because we know in geography there's also the time budget, but both could be covered in the contextual distance. So if you have access to a motorway, to an expressway, to a toll expressway, and if you only have a few euros in your pocket, you may quit the toll highway beforehand and continue with the non-toll highway. So the budget you have beforehand, before you go into your car, can have an impact on the itinerary you will choose, and hence on the distance, on the time distance you will produce. The same for available time budget, which is well known in time geography. So depending on the time budget you have, you may choose different travel options. That's very well known. But it's also the case for, wait, 1 minute left, thanks. Fuel, battery level, food, tiredness, etc. Time can be considered also. Arrival time, starting time. If I want to arrive at one level, at one precise moment, my trip will be different. So my distance will be different. And to really conclude, sorry, not geographical distance. The most important thing is contextual distance shows that geographical distance, to really understand geographical distance, you have to consider elements that were not previously included in the distance itself, but were considered in other elements, and it's all the resource related to context. And we propose here a distance that is more relative to context and more subjective. So that's all for me and the references. Yeah, thank you.
Thank you very much, Alain. We have one more presentation before we go to our discussion, and that's from Didier Josselin. Hoping but after all of these mispronounced names, I might have guessed that one right. Didier, are you there?
Yes.
Hi.
I'm trying to share my screen. That's it. I don't know if you can see it. Yes?
You can see it. Thank you.
Okay. Thank you, Alain, for this presentation. And it would have been very nice to meet Ron and all the colleagues in Manchester. I'm very sad not to be there, but next time. So I will address somehow a little the issue of the distance in another point of view. Because I try for a while, for a few years, to design a second geography law or law geography following the Tobler's one. And it is very different from the Tobler's law. So first, I would like to show you how the Tobler's law is very efficient and very cited and plebiscited in the world. So you may know the first law of geography of Tobler, which is everything is related to everything else, but near things are more related than distant things. And this works for many things, many disciplines. If we have a look on a quick look on history, there are a few French colleagues who investigated the work of Tobler, Colette Covin and also Claude Graland, for instance. They popularized his work. And there was also in 2004 an American forum about the TFL, the Tobler's first law, that showed that this law was simple but very efficient because it is the foundation of geography indeed. There's no isotroping space. You have a spatial autocorrelation. This imposes some interactions due to distance and gravity models and so on and so on. I will not go into details in these papers, but for example, Hecht and Moxley, they provided a paper where they proved that using 22 different languages in many articles, many texts on the web, on Wikipedia, with an accuracy of 50 kilometers, they proved that this law was efficient. And then this year I found a paper from Cressy. You may know he's one of the popes of geostatistics. And he wrote this: the primary feature of spatial statistical models is that nearby attribute values are more statistically dependent than distant attribute values. This is a paraphrasing of what is sometimes called the first law of geography. So as you can see, this law is not dead, and there are about almost 10,000 of citations of this law. Oh, how can I go down? Okay. There was during the discussion in around 2004, it was based from the depth of the distance. That was a key sentence from Cook-Lelis, you may know. And she stated 3 hypotheses. The first one was the distance is completely dead. The second one was there still exists a distance effect based on some figures that the geographical classical distance. And the hypothesis 3 was there is still, again, the distance, but it's very complex to appreciate and to comprehend. There was some tries to not contradict, but improve the Tobler's law. The first one was from Monteiro Fabricant and Ali. They added a cognition aspect of this law, and they found that people believe closer things to be more similar than distant things. And they used the experiments in geovisualization. Also in the discussion of the forum in the American forum, you can read from Goodside this sentence, which is very interesting in my opinion. TFL, or spatial dependence more specifically, be better treated as the second law of geography, whereas spatial heterogeneity be the first law of geography. So this is interesting because the first law would be heterogeneity, and the second would be the difference. So a second order based on distance. If we come back to Alain's presentation. And there were some tries to design or to define a second law of geography. So Ashton Mosley, I already cited. They said, and they noticed that there was an effect of scale. Everything is related to everything else, but things observed at the coarse spatial resolution are more related than things observed at a finer resolution. It is very interesting because it mixes scale effects and distance effects. And then we had from economics a definition in 2017. Things that know where they are can act on their locational knowledge. Spatially enabled things have increased financial and functional utility. So they say that when you know where you are, when you know where the others are, you are better in this relation of distance in space. And now I'm going to present my own definition of the second law. This is based on what you currently, maybe you've heard in the literature, between efficacy, equality, equity, all these meanings of what a territory or a service should be for people in space. Efficacy, that could be this. You have standard buses, you have regular lines, and you serve preferentially the core of the population. Equality, you have the same service everywhere. It is spread, there's no preference, especially. And equity, you know you have impaired people, and so you have to help these people to move, and you will develop on-demand transportation to compensate the problems of impaired people. So in my case, I work on what we call the K-facilities location problem from Hakimi. You have also a good paper from Peters and Thomas who generalized it in LP norm. LP norm is what we call also the Minkowski distance. And this is, as Alain said, a minimum of a global distance, which is the sum of the distance between the demand points and the center, with an exponent of P, which is the norm, the value of the norm. And then all this factor is has another exponent, which is 1 divided by P. If you consider P equal 1, this is the minimum of the distance. With P equal 2, you find the minimum of the square root of the sum of the squared distance. And if you consider if you tend the value of P to the infinite, then you get the minimax operator. So you will find the center which is the closest to the farthest people in your space. So what is the meaning of the centers? This is funny because when we speak about efficacy, this is an economical efficacy is an economical concept or objective. You minimize the sum of the distances. For example, if you want to set up a logistics center, and this refers to Weber or Fermat point or center. At the opposite, if you look at the equity, this will refer to the Rawls point. Rawls, because he wrote theory of the justice. So this is a kind of economical versus social center in green. And in this case, you will minimize the maximal distance. So you will compensate some problems for impaired people, for instance, as I said before. And in the middle, you have something which is used in geometry, but not very used in geography, in GIS, which is equality, where you will minimize the sum of the square distance. In this case, you have an exact operator, which is the mean of the coordinates, easy. So you can find some centroids like this. But if you want to minimize the sum of the distances or the sum, the minimum of the, if you want to minimize the maximal distance, then you will have to use an algorithm with a gradient descent, which is not exact, which is approximated. So what we did, in 2014, we used some concept of sensitivity, spatial analysis sensitivity. We just moved a little the demand points, and then we observed how much moved the center according to this little location changes of the demand, each point after each point. So this is a kind of empirical derivative. And then we computed that we made some papers and we computed that for all the points. It's a paper in environment and planning you can retrieve easily. And what we noticed, very interesting results, is that there is a strong and I would say generalized linear relation between the distance to the center and the weights of E. This means the influence of the demand point. This means that when you moved this point I, it has an impact which is more or less important on the center location. And this is what we call WI, which is here. I don't know if you see my hand here on the screen. And then what we noticed also is that if we use a log of this weight, this influence of the point, compared to the distance between the point and the center, given a norm, okay, the difference between this factor and the norm is always 2. So we can generalize all these models to all the norms by this model. Log of the influence of the point I equal to P minus 2 log of the distance plus a rest. So this is equivalent to this. So we found this by experiments, and today we demonstrated it, and we are making a paper to publish it, and that's what I'm going to show you now. So let's have a look on what is efficacy. The case of a logistic center, for example. You have here an example of when it's red, this means that the points have a higher influence. So WI was higher. Same here. It works also on the networks. So what you can see, if you replace P equal 1 minus 2, then you obtain this. You have an inverse effect of the distance. This means that closer you are, higher is your influence. If you look now, so I had this with that appear. If you look now at, I don't know how to, okay. Do you see this scroll bar at the top? No? Wait a minute.
Yes.
Sorry, I don't know why it came. Okay. It's better now, I think. No?
Now we can't see the screen.
Okay. So I pass to equity. Equity, if you replace, for example, you tend to infinite the value of P, you use 4, then, yes?
We can't see your screen.
Oh, sorry. Okay.
Better.
But I have a problem on my screen. I don't know if you see this scroll bar on the top, no?
I can't see it now. So.
Okay, so it works. So if you make tending P to infinite, for example, if you take P equal 4, you have this equation. This means that the distance has a squared effect on the weight of each individual. If you consider now efficacy, I cannot see it here. No, another example is if you choose P equal 1.5, which is a compromise between efficacy and equality, then you have this mathematical formula. If you consider what I call equity is the compromise between equality and equity. So in this case, this is a P equals 3. And this is a very interesting norm that does not exist in the literature. It's a new approach because there is a linear relationship without log between the impact of the points and the distance. This means that when you are farther you are from the center, proportional is your loss of impact of this center. So you can imagine how this can be used in management to settle new centers. So if I do a summarize of these norms, I would say phi KC, okay, P equal 1 is very used in GIS. P median, K median, you will find in the literature. Equality, this is used to design centroids. Equity, you can find it to compute P centers, K centers, even in GIS like ArcGIS and so on. If you now look at equity and efficability, equity is very interesting because it's a linear relation between distance and the influence of the points. And efficability, what I call efficability, is unknown in use but a good compromise. And you have a set of P values because you have in a generalized approach of the distance from Euclidean to non-Euclidean distance. This includes it, this encompasses all these norms. This is a generalization of all the optimal location methods in isotropic spaces. Now I come to the proof. We just proved that the solution of a center P given a norm, center C, sorry, given a norm P, is the solution, is a derivative of this primitive. And if you calculate the primitive, you will find this exponent P minus 2 in one dimension. So this is going, this is an article in preparation in geographical analysis to be submitted soon. And we also generalized it in 2 dimensions with my colleague Daniel Goyon, who is a mathematician. And he proved that effectively this weight of a point on a center is completely dependent of 2 factors. The first one is the distance between the center given the P norm and the individual that we consider, with the exponent P minus 2 we just spoke about before, divided by something which is a denominator that includes all the spatial structure of the domain points. This factor here is completely dependent of the spatial structure of the domain. So this is a constant according to a given spatial configuration. And if we simplify, this is completely what we observed empirically, but now it's demonstrated. Just to summarize before conclusion, here you have a plot, a map, not a map, a plot, that in X here you have the batch of data only on 11 individuals. You have the value of the norms, which are here. So here you have infinite norm, here 2 norms, second norm. Here you have you find again the efficacy, and here you find my 2 new propositions, which are equity and efficability. And what you can see is that when you simulate all this data, you will see the change of the shape between the relation between the weight of each individual and the distance to the center. It comes from linear with 3, sorry, to flat with 2 because each point has the same influence. And then here you retrieve the influence when the points are closer to the center. And here you can find the opposite. Only the points on the Chebyshev circle have an influence on the center. That's why the curve is the opposite of this one. So now I just come to the conclusion. If we look at the Tobler's law and my law, Tobler's noticed that the non-regularity of space has an effect on the relationship in space, of course. So there's a distance effect. In my side, I have also a distance effect, but not the same one. Tobler's has special relationship effects. In my case, I have a relation to the center. He noticed an impact on territories. In my case, it's more an impact of space. There's an effect in Tobler on individuals relationship. In my case, this is the individuals that defines the influence, and then the influence on the center. Tobler's law is very simple in comprehension and definition. I think mine is more complex. Mine is hidden in the matrix. It's written in the matrix. It's more visible with the Tobler's law. And there is the effect of the context on the Tobler's law. Mine is somehow immutable. It's because it is engraved in the metric. And so I would like to just to open the discussion. If we come back to the Cook-List hypothesis, according to new networks, social networks, internet, and things like this, does the proximity has now a strong importance in the distance? The distance influence will the distance influence be fade due to digital society and IoT? That is the question. That's not a conclusion. That's an opening discussion. Thank you.
Thank you very much. That was fantastic. And now we have some time for that discussion you mentioned. This is an open forum. I'm going to ask you to stop sharing your screen, Didier, and we can put it in a grid view and then everyone can see each other.
Yes. Well, I don't know how. I lost the part of the.
If you put your mouse to the top of your screen, it should show you that option.
Yes, just a second. I don't know where is the main. Okay. How can I stop to share my?
There should be a bar at the top of your screen, and to the right, there should be an option to stop sharing.
Oh yeah, okay.
There you go.
Thanks. Sorry.
I'll put it on gallery view. We can all see each other now. Anyone who wants to take the camera on, turn the camera on, will be welcome in the recording. This is an open floor discussion, so if you have a question, just unmute yourself and say it. If you don't feel comfortable, you can put it in chat. I can read it for you, or the person you wrote it to can answer in chat if they prefer. Any questions off the bat?
Hello, I have a question.
Hi, John.
Hi.
Yeah, I just thank you, Didier, for your presentation. I think it's very impressive because the first law is one of the topics I discuss a lot with my colleagues since the period when I was a student. Here I have a question based on the metrics you have proposed, because the metrics you propose have attached to the meaning like equity, efficacy, or equality, or some interconnections among them. But I think those are all ideas that's coming from the standpoint of humankind. However, for the Tobler's first law, it's not really restricted to the humankind. Like if there's no human, there's still idea of the near and idea of the related regarding the attributes. So I want to know, if there's no human, what impact will that impact to your definitions of the metric you have proposed today? Thank you. I hope I make myself clear.
Yeah. Thank you for this question. I completely agree with you. My idea, my law is human centered. I mean, this is the impact of how people can use amenities or facilities on space, because it is related to the optimal location problems, you know. So that's the main difference with the Tobler's law, because Tobler's law can be, of course, is more. That's why I said it's more geographical, Tobler's law, and mine is more spatial in terms because the distance is a weighting in my meaning, whereas Tobler's law is more related to even environmental locations and places, you know. So of course, well, I think it's not an extension of the Tobler's law. I think it's something quite different. It's like if you look in a mirror and my law is behind the mirror and Tobler's law is in front of the mirror. What I want to show is that you cannot ignore the impact of the metrics, even a generalized matrix, which is the Minkowski distance, which is from Euclidean metric to a much more complicated matrix, non-Euclidean distance. So that's my main idea. But what I expect to do is to show that according to the purpose of your center, and so you would choose the appropriate metric to locate the center. You have an effect of the individuals which is really different, and you cannot ignore it. If you want to build, for example, a center which is robust in time, which is sustainable, this will have a strong impact, because if you look at the minimax operator, if you have only 3 people that are the farthest people, so your center doesn't move, because you can move 99.99% of the people in the Chebyshev center without any effect on the center efficiency. If you use the metric, what I call equity metric, the Rawls point. So this is not how to say. It is very difficult to make the relationship between the meaning of the metric and the effect on space of the influence of the people who participated in defining the location of the center. That's quite complicated to explain. I'm sorry, but
yeah, it's okay. I feel I will better term it's not a law, but it's more like principles, and it's more like the urban planning focused. That's kind of my 2 cents of thoughts.
Yeah, but if you look at the Tobler's articles, it is not. He did not edit it as a law. It was a principle. It was written the sentence, but in the Detroit paper about in the paper about Detroit, there is no law. It's not. At the end of my presentation, I found another paper where he spoke about more numerical experiments, and there's a kind of law, but it was not proved. It was just captured by other scientists and then discussed as a global principle, and that became a law. This is very interesting.
Definitely. Yeah, thank you very much.
Thank you.
Anyone else have anything to ask? It doesn't have to be just for Didier. There are any questions that you have for the previous presentation, so we'll welcome you too.
If I can, I have a question to Alain. Okay. Well, I was surprised that so many works made mistakes by mixing routing and distance. I agree with you. I was wondering if you can put within the distance, the meaning of the distance, some a combination of factors just to ensure your model. For example, the distance should be not only a sum of time, but you can also use multi-criteria approaches to combine them. And in some multi-criteria optimization methods, you would be able, I think, to get the same results as your proposed suggested. And the other, I had another question, which was about the, you know, there exists also, you may know the parameter approaches. They consider that a good solution is not a minimum, but you have a Pareto front, and you have a mix of parameters. And if you can be good on one and not good in another one, if you don't have a better solution in one of the two parameters, you still have a good solution. So this is related to the previous question also. How can you deal with multi-objective approaches in your method?
Thanks a lot, Didier, for your observations. My view is any kind of optimization process works. I mean, there needs to be an optimization process. It can be complex, can be simple, it can be it can be as complex as Pareto, why not? But it has to be, the idea is you shouldn't use as a distance a measurement which would be not optimized, not the optimized one. So if you look distance in time, and then you switch to kilometers, and you say, oh, there's a problem. Of course, there's a problem, because if you optimize by time and then you look at another criteria, you produce. I mean, your reasoning is a failure. But just to answer my understanding of your question is absolutely yes. If you include in the measurement of the distance a complex optimization process, you will produce a distance. So you will have the same behavior as time distance or other kinds of distances.
So your definition works upstream to the optimization method. That's what you say in substance. It's before. Upstream. I mean, it is sufficient to feed any optimization method.
Yeah. Yes, okay. Absolutely. Yeah.
And I have also another remark. For me, the main problem of the geographical distance on networks is, as you said, they are not real distances, but it's not due to triangle inequality. It is due to non-symmetry. Because, and then you have what we call a quasi-metric. A quasi-metric, it is a metric which loses the property of symmetry. And I'm not a specialist of this, but I know some mathematicians work on this, and these are specific properties. And the problem for me was not in my meaning triangle inequality. It was much more non-symmetry, which is another problem. But anyway, I agree with you when we proceeded the DRT optimization algorithms, and we always had when it's well designed, we always had a triangle inequality respected. So that's not a problem to make optimization. Instead, in the cases you cited, but the problem for me is non-symmetry.
Okay, very interesting, because I didn't study non-symmetry so much, but I'm glad to get some literature on non-symmetry, because non-symmetry is in my view was less prone to geometrical problems, but you seem to tell me that I'm wrong.
No, well, I don't know if I'm right, but in my feeling, if you go to a point to another in town, if you have a one way to go there, it's not symmetric in geography. I mean, it can be, but it can occur that it is not symmetric.
No.
But it has no effect on the triangle inequality. People think that it has, but it does not. I agree with you.
Good to hear.
Yeah.
Good to hear. Yeah, but maybe I have a question. Or if
just one comment. It was so interesting to know that the discussion on the asymmetry or heterogeneity of the distance is well analyzed in the mathematical field. I'm from economics, but even the same distance of one direction or the other, as you mentioned, if the demand of one direction is larger, probably the cost or the price may be different on the same distance. So all of your discussions were quite clear and provoking some questions to me. So thank you very much. I enjoyed your discussion. I cannot make some comments additionally to you, but interesting, and also the summarizing that the presentation from Didier was also very interesting to see that how all of the different criteria can be shown in a quite simple equation with different parameters. Thank you very much.
Thank you. I appreciated a lot also your presentation. I had a question online, so I can ask it to you. You know, in France, we have an objective. I don't know if it's same in Germany or in UK. I think if I remember well, our objective is to reduce carbon emission of 50% up to 75% in 2100, which is so when I see your results, I'm not optimistic, but it's not due to India, it's due to the world. In France, I don't know if we'll succeed. And well, that's and I found very interesting what you showed about the balance between economic and some objective of environmental objectives, because generally we don't link the effects with each other. But well, that's hard to hear. Your results, it's only a few percent. It's hard to hear.
Yeah, you already have the high-speed railways, so yeah, you need to have much faster one probably with less CO2. I don't know. We have such a technology, but we hope to have it before 2100 or the one you said.
Any last comments to add before we go for a quick lunch break? Anything anyone wants to say? All right, in that case, make sure that you don't miss the keynote lecture from Professor Batty at 2 o'clock. Please attend. It's going to be fantastic. Thank you all for coming. This was an incredible discussion and very lively, a lot of fun. And the presentations themselves were also great. If you're here this afternoon, I hope you'll see me in Perceptions of Urban Space, but obviously go wherever you want to go. Thank you all for coming. I'm going to stay in this room until everyone's left for the recording, but I'll see you all very soon and have a great afternoon.
Okay.
Thank you. Bye-bye.
Thank you very much.
Bye-bye. Bon appétit.
Thank you.